3y to the second minus 5y plus 2 equals 0.
Yes, because x to the 2/3 times x to the 2/3 equals x to the 4/3. And we said that this is y times y equals y squared because of the substitution.
Okay.
Okay? Right?
I'm with you.
Okay, you with me on that? And then clearly this is y because we said that y is x to the 2/3. So that's why this is
That's why that becomes
that's
y.
why that becomes y there. And of course nothing happens to the 2 and the 0. So we get this thing which now looks like a quadratic equation.
Okay.
Which now allows us to go into our toolbox and pull out our tool, the quadratic formula.
Right.
Okay?
And plug that in.
But which is where this comes from. We plugged in these coefficients. We took these coefficients and we plugged them into this quadratic formula, which you have to memorize, which is
b squared minus 4ac over 2a.
okay. So this is the quadratic formula. This is the tool we pulled out.
Right.
Pulled that tool out, and because of that tool in this quadratic equation, we get this step. See, this is
So 5 goes in the first 5.
yeah, because a minus 5 goes in for a minus b. So a minus 5 is 5. You
Oh,
see?
so it's plus or minus 5.
And this is plus or minus whatever's in here. Okay, ask me again. I don't. This is a minus b. When I put a minus 5 in for that spot, substitution,
Yeah.
okay, I get a minus 5, which is a positive 5.
So it's basically it turns it into a positive.
Correct.
Period.
Correct. Well, if it had been a positive 5 here, then it would have been a negative 5 here.
Okay.
Because it's a minus whatever that thing is.
Okay.
Okay, sometimes that thing's positive, sometimes that thing is negative, okay?
So, and then the square root of 5 is 25.
Yes, but I have to do all this arithmetic here first. I have to do 5 squared minus 4ac. 4 times 3 times 2, because here's a, 3. Okay, so this, 24 is 4 times 3 times 2. Okay, 4 times a times c gives me 24.
So 4 is always part of the formula.
Yeah.
Yes.
Yeah.
Yes,
that-
this
that
2 and this
always
4
is the
are in
same.
this square root sign. This is always in there.
Yeah.
Okay?
I'll have to write that formula down.
I told you.
Well,
And you just got to memorize
We're doing a
it,
whole
and
bunch
you got to
of
do a
shit
little
here.
practice with it, so it's not too. You know, even after you have it memorized, before you do some practice with it, it's a little. You know, the tools. You know, you flip it and you drop it. Okay. Now, okay.
That
When
becomes
I do all this arithmetic, I say 25 minus 24 is 1.
Yeah.
Square root of 1. That's where this stuff comes from. This is 5 plus this, which is 1.
Okay, so then that just becomes 5 plus 1.
Yeah, that's right.
And because you're trying to square it,
And
you
because
have
it's
to
plus or minus, we also have 5 minus 1. See, this is plus or minus right here.
Uh-huh.
So when I find out that this is 1, I have 5 plus 1 and 5 minus 1.
Okay.
So I get two results. Okay? Then when I do that, I get 5 plus 1 is 6. 6 over 6 is 1.
Yeah.
5 minus 1 is 4. 4 over 6 is 2/3. Okay? So I've now found out that y equals 1 and 2/3. But I don't care about y. I care about what I set y equal to. So I say, okay, if y is equal to x to the 2/3, and these are all the same. Okay?
Okay, so x to the 2/3 then becomes 1 and 2/3.
Yes, because I unsubstitute. You know what I mean? At first I substitute, now I sub my thing back in.
There it is.
Okay? And now we're probably at the spot where Sam had some questions.
X.
And now I don't want to know what x to the 2/3 is. I want to know what x is. So I want to get rid of that exponent. And the way I'm going to get rid of that exponent is
You just cancel.
I'm going to multiply. I'm going to raise each side to the 3rd power because that's going to get rid of the denominator. So then I have x squared equals 1. Now I still have x squared rather than x. If I take the square root of both sides, I now have x, and I have x equals plus or minus 1. Okay?
Okay.
That one was.
Now this one here, I got to do the same thing with the other answer that I got. I also have to do it with this one. I have to say, hey, I have to cube both sides. And what happens when I cube this side is I get x squared. What happens when I cube this side is I get 2 times 2 times 2, which is 8. And I get 3 times 3 times 3, which is 27. So now I have x squared equals 27. I don't want to know what x squared is, I want to know what x is, so I take the square root of both sides. So this goes, square root of x squared is x, square root of 8 over 27 is the square root of 8 over 27. So I just write it that way until I can figure out what it is.
Can you?
Yes, I can get my,
So 8 and 27 are placeholders.
there's this placeholder until I can do that. You know, I got to do some simplification. You know, the stuff that we learned in chapter 8, now have to do. Which means, well, one of the things I learned in chapter 8 is I can take this and split this as a square root of 8 over the square root. I mean, I'm supposed to have, yes, square root. Square root of 8 over square root of 27.
So up on 2.
So
Okay.
2 times,
So plus or minus 2 times the square root of 6 over 9 has to look this way. So we have this one more turning of the Rubik cubes in order to get the sides all, you know, colors all the same.
God, this is brutal.
So the top one is the question, right? Because I was writing notes. Which one's the question? Okay.
This one, so when you follow my trail, like a slug, I leave a little trail where I go. Then you follow the slug, you get down to here, okay, and you get this, and so I took that and I moved it up here so we could just look at it. And then I said to you guys, there's something fishy about this one. You're supposed to know there's something fishy about this one. Can't have 0 in the denominator. We can't have
You can't have
Times.
a
you can't have
radical.
a radical in the denominator, and you can't have an imaginary number in the denominator.
So 3 times 2 is 6.
So we have to-
3 times 3
yes.
is 9.
So, yeah, square root of 3 times the square root of 3 is 3, so 3 times 3 is 9. Yeah. Okay? And yes, 2 times that, that's where the 6 comes from. So you have to do that one little word problem. It should be a piece of cake. Because what we did to the 81, we probably want to do to the 27. We look at
3
the chart.
times 3.
What is the cube root of 27?
3 times 3.
It's 3.
Three.
Right?
So it's 3
3
times
cubed.
3 then.
So
Or
it's
3
it's-
exponent 3.
Yeah, it's 3 to the third, which again, 3 to the 3 over 3 is just 3. We just take the 3 out, okay? Or we can go through this whole, every little itty bitty step if you want to,
I'd like to.
okay? And I think doing every little itty bitty step is okay to start with, but you want to get going faster. You say, okay, I got this now. Just take that 3 out,
So a lot of it is recognition.
always,
Repetition.
No,
Recognition.
recognition.
all those R's.
One of those.
Reconnoiter, repetition, recognition.
Concentration. Okay?
Who's on first?
Better than a suppository.
And then, like you're saying, 4 and the 12, the 3 and the 6, we're going to have an X. This is. Okay. Now, if you want to see the intermediate step, which is why this is true, you go like this. You go, this is 3 to the 3 over 3, and this is X to the 6th over 3. Okay? Which then again, if you want, or if you're really anal, you want to do it that way every time, just go ahead. Certainly not going to go wrong this way, just going to be slower. Okay?
Well, I have to do that in order to understand it.
And I agree, which is why I'm willing to do some of these like this, because that's how you understand. Once you understand, you no longer have to do it that way.
And if you never understand, you'll always be doing it.
All right,
Oh,
bud.
the 32 is part of it too.
Yeah.
I heard that.
Because this one, we want to go back the other direction. Okay?
You want to turn it into
You want to turn it into
a
something
square-
like
a
this.
square root.
Yeah, okay? So 7C, you're gonna do,
Where do you get
again,
C
you're gonna
from?
take, you're gonna think about 32, and you're gonna
C.
say, you're gonna look at your chart, see how the chart comes in handy?
Bottom of 4.
32 is 2 to the 5th.
Oh, well, that's what.
So this is 2 to the 5th, x to the 5th times 3/5. And we're not gonna have to turn it back to the radical because it's gonna cancel. Right, when we multiply 3/5 times 2 to the 5th, the 5's cancel, and we get 2 to the 3rd. When we do x to the 5th times 3 to the 5th, the 5's cancel. We get x to the third.
See, I'm gonna have to do it all the way.
And it looks like we're done, except for we want to take 2 to the third. Look on our chart, see that it's 8. We want to write this as 8x cubed.
Equals 2 to the third, x to the third equals 8.
Right?
Mm-hmm.
Okay. There's a little trick that we talked about last week. Okay. When we do that, remember our rule here.
Oh,
Okay. Cancel.
so you turned the 8 into a rational.
Yeah, I turned 8 into an exponent. I said, remember what we said is, if you have these fractions and you have a number, check to make sure that number can't be written as an exponent, because you're going to get canceling. So this is a little bit simpler than doing it this way. Negative times negative is a positive. So if you have an even number, 49. Square root of 49 is 7. It's on our charts.
Uh-huh.
Okay. So this is minus 21 times the square root of 2. And now we look like we have like radicals. Now, again, we can ignore this and just do the numbers.
So,
7
4
times 3 is, okay.
Oh,
Now,
it's 0.
in this case now, are you actually subtracting, are we adding the negatives, like minus 25 and minus 21 is,
It's 0.
Same thing.
okay.
No, this is not 0. This is I've got $4. I
That's
spend
4.
25. I spend 21. I got negative something in my account,
4,
right?
yeah. Yeah.
Negative 42.
So it would be negative 42.
That's correct. Okay. This is my answer.
I gotta go back a little bit. Now, 5, square root 2, square root 25. What did you do to get the?
Square root of 25 is 5.
Yeah, I got
5 times the square root of 2 times 5 is 25 times the square root of 2.
So you're combining equations.
This is 5 times the square root of 2 times the square root of 25.
Okay.
Times, okay? When change this to 5, and I have 5 times the square root of 2 times 5.
Okay, there it is.
Which is,
Okay.
okay?
Why did you place the?
Okay, so
negative
I'm
three
confused
square
about the
root of
21.
Now, come back to the 21. Samara?
2? Why did you place the negative outside of the radical of the 49? Can you place?
Oh, that's just that my pen quit writing there for a little
Oh,
bit, okay?
Okay.
5.
21. Where'd you come up with 21?
7 times 3 is 21. Same way I got 25.
Oh.
Okay?
Oh, okay, the 7, okay, I wasn't seeing that 7, the square root of 49 is 7. Okay.
Sometimes I just, this is, forget that part. This is 5 times the square root of 2 times 5, which I'm going to reorganize as 5 times 5 times the square root of 2, which is 25 times the square root of 2, with that negative sign. This one over here is minus 3 times the square root of 2 times 7. I'm going to reorganize. Minus 3 times 7 times the square root of 2 is minus 21 times the square root of 2.
Okay.
Okay?
Okay.
Okay? And just to me, all this needs to be done right in the head. It needs to be written down. But
So the easiest way to do
leave this, we're going to say, hey, this is 7 of these
7.
guys.
Minus.
7 square root of 2x. And then we got a minus 22 of those guys, and we're done.
So that's the answer.
Can't, because we can't
Go ahead.
combine, they're not like. Clearly 2x and 5x are not the same looking thing.
So the answer then is
This.
7.
that. You can't reduce it any further.
Can't do
It's-
anything
it's
more to that
small
one.
as it's gonna get. Okay.
At this point.
I can live with that.
My question earlier was, okay, so now, how would you,
Some headaches.
To a lesser being, that would be true.
As long as we just don't let it get to us.
which one is that?
Yes. The definition for complex has my picture. get any easier looking at it like that either. I know.
A squinting help. You know, 54 is 2 times 27.
If you say so.
Yes.
Yep.
Okay? So, like if I take that and I make that as the square root of 27 times the square root of 2 times the square root of x times the square root of x cubed.
Can you do it like that?
Why?
All factors.
Where the x cubed come from?
Yeah.
Well,
So then you can take
I'm
out the
just showing
3.
you how come my x is going to come out of here. X times x cubed is x to the 4th, right?
Right.
Yes.
Why do I want to have a 3 here? Because there's a 3 out here, and that means that that x is going to come out. It's going to be simpler. Less stuff in the radical. Okay? When that x comes out, I get x times x. I get x squared out here. And when this 3 comes out of there, because 3 cubed is 27.
Mm-hmm.
Okay? So 3 comes out. 3 times 3, I get 9x squared out here. What's left?
There's 2x.
So I got 9x squared times the square root of 2x.
Lost with the x squared. How did you get the x squared out?
I took this x out,
Yeah.
and x times x is x squared. There's
Okay.
x already out here waiting.
Okay.
All this is multiplication. See, it's all multiplication. So I could write x times x, but it's x squared, see? Just like, well, it's the same as the 3. So you weren't thrown off by the 3 coming out. 3 times 3 was 9, but you were thrown off by the x coming out, x times x being x squared,
Right.
which seems to me shouldn't be. It's the same thing, yeah.
Yeah.
So you pulled the x out, not the x to the 3rd.
Yes, this came out.
That came
Came
out.
out as an x, 1x.
Because the 3's canceled.
Yes, because x to the 3 over 3 is x.
Are you sure? Okay, yeah.
Now, let me go over here and work on this one. Think about breaking it. This is square root of 8 times the square root of 2. Why? Well, I want that too, because I think I'm going to be able to add them together if I can get them to match.
Or at least subtract them from each other.
Or subtract them. Well, to me, addition and subtraction are the same thing, but, okay, then this is also x cubed times x cubed times x over here, right?
Yes.
Because 3 plus 1 is 7,
Mm-hmm.
okay? Each one of these gets to come out because the 3 over 3 cancels, right?
Okay.
Okay? So a 2 comes out, 2 times 3 is 6, and x times an x comes out, which is x squared. Left inside, square root of 2 and an x.
Oh, God, you make this shit look so simple.
And lo and behold, we now have like terms.
So
Okay?
that it
Now I can
becomes-
subtract. Forget this. Subtract 9x squared minus 6x squared. I get to forget the x squared. 9 minus
It's
6.
just 3.
3x squared times 2x. This mess here becomes this mess by simplifying and then adding like terms.
Okay.
Okay? Now, some practice with that. Oh, yeah. Stay focused. I got 7a up here.
75 over 3. Okay.
You're the one that told him to
Square root
do
of
it.
25 is
25.
something that we know, or we look on our chart, pretty soon we know.
So it's
5.
5.
So it's fun.
That's simple.
Okay?
It's simple, but
Pretty easy.
Very simple.
complex.
Now, a different look, see, going the other way is B. So when you look at 7b, which is down right, cube root of 27 over 64.
Uh-huh.
Okay? This one, it's no advantage for us being in a single fraction inside the radical. The advantage is if we split it up into 2 radicals. So again, we take the rule, we just go the other way with the rule. Okay? So this time we took it and put it like that, but now we've got it like this, and we're going to go to this one, you see? Okay? So we take this as the cube root of 27 over the cube root of 64.
Okay.
Okay? Same rule, just the other
Following
direction.
you.
Okay? Now, the cube root of 27 is on our chart.
It would be 3.
3.
Three.
Okay? And the cube root of 64 is on our chart. It is
4.
4.
Or 4. Is it 4?
Yeah.
I mean, so this is, just, you know,
Yeah.
3/4 disguised. Well, that's what happens when you multiply square root of 3 times the square root of 3.
Oh, okay.
You get square root of 9, which is 3.
Okay.
Okay, which is kind of the whole point. Okay. Now, I think this is a pretty easy idea.
So then in that area, would it be 21 over 3 then?
Well,
Take it further or no?
No, you don't take it any further. You would just leave it like this.
Just
Okay,
leave it like
this is
that.
as simple as you can make this radical.
Okay.
Okay, it's a little bit like a variable. We're not going to bother to figure out what the actual value is, although you could. If you got your calculator with you right now, you can tell me what the square root of 3 is. Okay. Or you can get a slide rule, or you can check a table. But you know, you just leave it like this, and when you get to the point where you need to know what that number is, then you can crunch it. You know, with your computer. Okay. Or your smartphone, or something, and just crunch that number. Okay.
Done, right. But I got close.
You got paid. That's all that counts.
Well, you know, again, like most problems, you could simplify this before we started x on the bottom, and up on top you get
Okay,
4
right,
times the
right,
square root of 5x. Okay, and then I think this is the answer.
That's the simplified answer?
That's practice problem 9.
Yes.
Practice problem 9. Okay, now, going this route is still gonna work out, because we get up here, we have to do this work that we did down here anyways. We have to take this, okay, and pull that 2 out.
Yeah.
Okay, and so you're going to get 16 times the square root of 5x over 20x, and now you're going to cancel this to 4/5.
Okay.
Okay, so this is 4 times the square root of 5x over 5x, and we get, you know, we match, because what thing you decide to do first doesn't change. You still have to keep working your way all the way down till you get it simplified. Okay? And for some people, going this route makes more sense to the way their brains are kind of wired. Okay?
Until you can skip that section there.
You know, I don't know. I like to simplify first because I get smaller numbers. 16 and 20 are not numbers so big that would discourage me from doing it this way.
But they're still a pain in the neck.
Okay, but there would be numbers that would be very much a pain in my neck if I didn't simplify them first.
Okay.
So just like with fractions back in the day, you know, cancel first and then multiply.
Okay.
Don't multiply first and then cancel, because you're going to get bigger numbers where it's harder to find the factors to cancel with. Keep your numbers small, and then you can do it in your head. Okay? Keep your numbers big, and you might get ones that you can't do in your head, but 16 and 20 are numbers that I can do in my head, and most of you can.
4 and 5.
You know, 4 and 5. And so it's not, it wouldn't matter which route, equally easy, efficient. Okay? And really that was the difference from practice, the first practice problem on this concept. Now, up here what they've done is added what we learned earlier in the section, plus raised the exponent to make this one a little bit of a puzzle. Okay? A challenge for scenario.
She's all, thanks. Thanks a lot. Good looking out.
And so, I mean, what will we do? We could say, okay, this is the cube root of 6 over the cube root over the cube root of 5x. Okay? And then we say, well, gosh, we need to rationalize the denominator, so let's multiply by the cube root of 5x.
Wait a minute.
Huh?
Wait a minute. Hold on. Something's not right there.
Yeah.
What happened to 6?
Yeah.
Oh, well, okay.
It's not double.
No, the 6 is right here. No,
Is
no.
that?
No, but after you multiply the 3 cube root of 5x, where is the 6?
Well, I haven't done anything yet. Just wrote down 1. This is 1.
How, why
What?
is it 2?
This is 1. I'm multiplying by 1 like we talked about the rationale as an operator.
Why are there 2 sets?
Okay, good. Now you're asking me a question that makes heading towards learning here.
Yeah.
Why would there be 2 sets? Why was there only 1 set was squared? How many sets do you think it would be if this was the 4th root?
3.
How many sets if it was the 5th root? If I
Okay.
just multiply by 1 of these, I'm not going to get rid of the radical down here because it's the cube root.
Yeah.
Okay. Okay.
Okay, you see what I'm saying?
Nope,
Yeah.
not really.
I'm kind of getting it.
Well, I have 5 times 5 times 5. Remember, that's going to be 125
Oh,
x cubed under the cubed sign, which means I get to take the 5 and the x out, and I've now got rid of the radical down below, because this is to the 3rd power.
now it makes sense.
Okay, are you with me on that?
Yeah.
Now, there's a couple ways you could write this. You know, you could have written it, I wrote it that way. I thought this would be easier for you guys, but we could have written it like this. Like that. Okay, and instead of like this, but really this, I think, is an easier way.
That's actually easier.
Okay.
You can erase that complicated crap now.
That's just what this means. But now we still figure out, we figured out the bottom, okay? It was a little bit of a trick,
Yeah.
okay? And I don't think you guys would have seen it without me being here,
No.
okay?
No.
Or, you know, the book, I'm sure shows you too. That's not exact, but without somebody giving you a little guidance. But now at the top, what do we have at the top here?
We have a monstrous number.
We have 6 times 5 times 5, which is 30 times 5, which is 150, huh? 150x squared 3rd root of that. Okay?
God.
That's what we have up on top.
Uh-huh.
And then we have to think about whether we can simplify this. Is there something we can do with the 150? Perhaps, but maybe not.
You can drop it by 15.
You know, like 3 times, there's no good, the cube root of 27, cube root of 4 is 64, cube root of 5 is 125, so 27, 64, and 125 do not go into 150 evenly.
Mm-hmm.
So there's no way to factor 150 into something that's going to give me a cube root to come out.
So we're done.
So we're done. Okay.
Rather than 3, or in this case 2 plus radical of 5, it would be 2 minus the radical of 5.
Correct. Remember the difference of perfect squares. Okay? Remember when we FOIL those out, the middle terms cancel each other out.
Right.
Okay? So that's why we're going to use conjugates, because the middle terms will cancel out, the end terms will become numbers without radicals over them, and then you've gotten rid of the radical. Okay? So if you're looking at practice problem 11, here we have a problem that looks like this. Just multiplying by square root of 5 over the square root of 5 is not going to get rid of the radical.
No.
Because when I multiply square root of 5 times a 2, I'm still going to have the radical down here. So this is where we use the conjugate, which Jason seems like he's all over.
Yeah, it looks to be deceiving.
If we multiply by this as R1, okay, the conjugate of this, see?
They cancel each
The
other out.
middles are going to cancel out. This is going to be a whole number. This is going to be a whole number. No more radicals on the bottom. Are you with me on that? When I do FOIL, let's go ahead and do the FOIL the first time, and after that, you just trust that this is what conjugate's going to do. Okay? So when I do firsts, I get 4. When I do the inside, I get a positive 2 times the square root of 5. When I do the outside, I get a negative 2 times the square root of 5. And when I do the square root of 5 times the negative square root of 5, I get a negative 5. Okay? When I add those two together, they become 0. I get 4 minus 5 minus 1 on the bottom.
Minus 1.
Okay? And up on top, I get, I got to do all this stuff up on top. I get 8 minus 4 times the square root of 5. And then I can take that negative 1, or leave it. Let's see, does the book want to leave it? No, it didn't. I didn't think so. Take that negative sign out, this negative 1 out, and that'll make this negative and that positive. So this is negative 8 plus 4 times the square root of 5. Final little bit of.
So to get the top, 4 times 2 is 8. Where
So
does the
what
4
I've
come
done,
in?
what I've done here is multiply this by negative 1. Okay, to make this a positive 1 underneath here, and then I don't need to write it down. Okay, and then just flip the signs of the two things inside. These two things are the same thing. Okay.
You there.
In other words,
Plus 2.
Okay,
Extra step that I don't need there.
and then before I call it quits, I have to look at the square root of 55 and think about if there's some way I can factor it to take something out. Probably not. 55 is 5 times 11, both are prime numbers.
Yeah.
Probably nothing I can do to this. Then I think that I'm probably done here.
So, yeah, it's pretty
Okay? But occasionally this is going to be like if this had been 50, we take it into 2 times 25 and take the 5 out.
Yeah.
You see, and it would even get it simpler. Okay?
yeah, that is confusing, but it kind of makes sense.
Yeah, well, just following it through.
Least common denominator added
Okay,
together. So it
okay.
seems like fractions is giving Sam more trouble than the concept. Okay, and when you have to mess around with these fractions. Okay, that's from what I'm sensing, is the fraction part that's throwing you off. If you move it over, it's more straight up what you have to do. Perhaps if you move this number over.
If you keep your
Because see, now you see where my 31 ninths came from. Because 6 ninths and 25 ninths is 31 ninths.
Yeah.
Okay? So then I have x squared plus 10 thirds x plus 25 ninths. I have this. This is 31 ninths, and this is x plus whatever, 5, x plus 5 halves squared. Okay, and then you can see that it doesn't,
right.
isn't any different. Okay?
Because I realize I think differently.
I think I got that right. Equals 2/3. And then we have to solve those. And in order to do that, we have to remember that we want the cube root of 1 squared.
Okay. 1 squared.
And we have cube root of 2/3.
Y
Plus or minus. Plus or minus. Think. Oh. Thirds. Plus 3 equals 1/3. We're going to go x to the 2/3 times 3 equals 2/3. The third. Okay. Which is going to give you x equals 1. Plus or minus. Plus or minus. The 5 halves. And what evaluate means is, what's the number that this equals? And what's, now I'm going to play psychologist. Sam says 13th Where did you get the number 13, Sam? What did you do to give you 13?
4 times 2 plus 5.
So you treat it as if it was a mixed number.
Yeah. Is that the wrong thing to do?
Well, it's not a mixed number.
Would it be?
Oh, it's not a mixed number because of the parentheses.
No, it's being raised. This is an exponent.
Yeah.
Okay? So, you know, like, I know this is not like grade school, so sometimes my writing is not necessarily, but, you know, if you're doing that, you know, rule letters, this is raised exponent, okay?
Would it be 10?
If it was 4 to the 5th, what would it be?
20?
4 to the 5th.
No.
Would it
4
be
to the
20?
5th power?
Yeah.
4
That's
times
a
4,
large number.
4 to the 5th power.
Pretty large
8.
number, huh?
Yeah.
4 times 4 times 4 times, okay, so 8.
7.
Okay, so 2 big
16.
fours, right?
Yeah, just a little.
30.
Because 4 to the 3rd is 64,
Yeah.
okay? So 4 to the 4th would have to be 4
Really
times
large.
64, which is 100, you know, 24 plus 16, 136. Okay, and then 136 times 4 would be 400 plus 120 plus 24, so 544, I'm guessing, approximately.
Okay.
Okay, so not 13.
Okay.
Here's the trick to doing these problems. They're going to pick a number in here that you can write as an exponent. Okay, and if you see a problem like this in your homework or a problem like this in the test, they're going to choose a number here that you can write as an exponent. What do I mean? I mean 4 can be written as 2 squared. Okay, are you with me on that?
Yeah.
Then because the rule of this, we're supposed to multiply 5 halves times 2. The 2's cancel, and we get 2 to the 5th. Can we do 2 to the 5th in our head?
Yeah.
2 squared, 4. 2 to the 3rd, 8. 2 to the 4th, 16. 2 to the 5th, 32. Okay? That one's a little easier to do.
Okay.
The answer, if we're asked to evaluate that particular thing here, is 32. The little trick to making it understandable is to take this number here, look at it, and see if you can think of it as an exponent. Okay? So, for instance, now look at the next one in the practice problems. 27
Be like 9 or 3.
raised to the 4/3. How can I write 27 as an exponent?
3
To the 3rd.
3 to the 3rd.
Third.
And, you know, here's a little hint. Again, they're trying to make these problems work for you. This little number is a hint as to what this is going to be, because it's going to make the canceling take place, you see, because they're trying to give you a problem that you can do without a calculator. Okay, you understand what I'm saying? So if I take this and I think of it as 3 to the 3rd raised to the 4/3. Okay,
The
when I
threes
multiply
cancel each other
4/3
out.
times 3, the 3's cancel, I get 3 to the 4th. And then can I figure out what 3 to the 4th is? Yeah, it's 27 times 3, 81. Okay? And again, if I'm going too fast, that's because we already know 3 to the 3rd is 27. We just got done figuring that out. I don't have to think about that anymore. I just can go 3 times 27, 81, away I go. Okay, so 3 to the 4th is 8. So if I'm evaluating, if I'm asked to evaluate, you see some kind of rational exponent, think about the base. See if you can turn the base into something with an exponent. I guarantee you will be able to, because that's the way they're setting the problem up. Okay? Haven't really taught us what to do about this exponent, rational exponent yet. We're going to find out some other stuff as we go through the chapter. So right now, if you just turn this into something like this, now all of a sudden it becomes something we know how to do. Okay? It looks like something we don't know how to do. We start, you know, flapping around like a fish out of water, and we guess 13, which is okay. You got a reason for it, or even if your reason is a guess, it's okay. It gets us started. Okay, that's all good. Okay. This first section's got. We might just add.
Yes, the flipping rule.
Hong Kong Fooey flip rule.
The flipping rule.
Is it
3x to the third.
1/3? You have 1/2.
Am I supposed to have 1/3?
Yes, that's okay. We'll forgive
Well, 1/3's gonna make it work better.
you. You think?
I do think so.
Don't you just love them?
So it would be x over 1/3.
Okay, and then we're asked to write this as one fraction with only positive exponents. Okay, and what do you think we're going to do?
And the exponents.
Does 1/3 and the 1/3, negative 1/3 cancel out to 1? That's not, that is it.
You could do that. But
You think we just add these together and we say that we now have 2x to the 1/3? Is that what you're saying? What do we have to do? Let's start here.
You have to flip
What does this equal?
one.
So this
over-
problem is really 3x to the 1/3 plus 1 over x to the 1/3. Right? Now,
the answer is 4. If you can, well, no, you can't cancel.
you can see that I can't add these, right? Because this has to have what for its common denominator?
X to
It has to have x to the 1/3 as its common denominator, right? So in order to get that, I have to go 3x to the 1/3 times x to the 1/3.
Okay.
Right? Now when I do that, what do I get up here?
3.
3x to the what? If I'm multiplying two things with exponents, what do I do with the exponents?
Add them.
I add them. 1/3 plus 1/3 is?
2/3.
2/3.
2/3. Oh, you add it straight across. Duh.
Oh, okay, right.
Okay, let me repeat what we did.
Okay.
Okay? Here's what it started out as. We said, hey, we've got a negative exponent. Tells us we don't want any negative exponents. Get rid of the negative exponent. Okay? So we changed negative exponent to a positive one, of course, which made us have a fraction. Now, because we have a fraction, we want to add these two things. They both have to have these common denominators.
So you have to multiply this.
So we have to multiply by this denominator, okay? It's 1, there's no equal sign, remember? No equal sign, so we multiply by 1. Because if we multiply by 1, it doesn't change anything, okay?
Right.
Except for now, we have this equal fraction in this denominator, okay? Then all we do is add the tops, add the tops. So these are our various transformations that we end up with the answer. Okay? You think you could do that at all? It's all be part of our system. Any common factors, the first thing we're going to look for. See if we can take them out. Okay? So if we have something like 4y to the what? Okay, I'm looking at practice problem 7.
4y to the 3 halves
Yes, minus what?
minus 8y to the 5 halves.
Okay?
So you can take out 4y to the 3 halves.
I think that we can. Okay? Again, I think you want to think about it in stages. You know, look at the numbers first. clearly we can factor something when we're just looking at the numeric portion of the problem.
So why?
You definitely take out the 4, okay? That's 4 times 1 and 4 times 2 are going to give me the 4 and the 8, okay?
Yeah.
Right? Then we look at the y's, we have a y in common, okay?
Right.
And
2.
Don't they, it's almost a y and 3/4 in common, isn't it? Or 3/2, excuse me.
we have a y and 3/2 times 1 minus 2. When we take out,
2 halves.
yes, and what is 2 halves?
1.
1.
And how, do we write 1 down?
No.
No. Okay. So all that's true. Okay?
Okay, well.
So if you really wanted to be goofy, you could write it like this.
Yeah, because
Because that would be
If you
proper.
really
And you
wanted
would
to be
understand
goofy,
that on the test, right?
Yes.
and if you really wanted to be goofy, you could write it like that. Because y to the 0 is 1. 1 times 1 is 1. And I had a 1 there, so you could do that.
if you didn't write the 2/2, how would you put, I mean,
You don't put the 2/2 in there, you just put 1.
I understand that, but how would you make it when you factor it back, I mean, when you
You just
multiplied
remember
them
this is-
together?
This is 1y. Okay, and so if I had to multiply them,
Okay, I'm not ready to make that shortcut yet.
if this is my problem on the test, this is like number 1 on the test, perhaps. Okay? What would I do? First thing I had to do is I got to think of, oh, this is y to the first. Okay? How do I add 1 to 3/2? How do I add 1 plus 3/2?
You have to turn it
I have to
into 2
get,
halves.
I have to get common denominator. Okay? 2 halves plus 3/2 equals 5 halves. See? But we wouldn't, you could write this as 5/5. It's still true. Okay?
Yeah, you could, but it'd be really damn confusing.
Yes, but it's just weird. It's just weird, see? Okay? So this is the answer. Okay? We don't write the 2/2 because 1 is understood. Sometimes you do have to add. If you had to add 1 plus 3/2.
But you wouldn't add the y over there. The 1?
What do you mean?
Yeah, because that would be
There's no
y.
y here. I put this in and then didn't
Right.
erase enough of it. Because y to the 0 was 1. Because we were doing goofy things, I said I'd go all out.
Right.
Goofy. They're steps. Shut up.
See, my problem is that in my brain, I'm still thinking, in the original problem, you can't separate 4y to 3 seconds. You can't do that. But you can because it's a multiplication, right?
No, you can
Where
because you're.
when he factored out the 4.
Well, the whole idea behind this exercise is to factor out the most common.
Yeah,
Part of
just
it,
like
right?
the other problems.
Mhm.
Yeah, it's just that we have the
Shocking. The orange shocking. But no, the problem.
No, I mean, the problem shocked me. I was like, oh crap, I know how to do it.
You really just walked in front of my camera.
You're really just gonna have to take the shot. I can't.
I can't even see. Could you write in a darker color?
The definition of a square root is here. If x is a non-negative real number, then the square root of x is the non-negative or principal square root of x. In other words, the square root of x squared equals x. Do you follow all that?
No, but I got a camera.
That's just in your purple box. The best way is to look at some.
Oh.
Okay, so, which we already kind of did a little bit of work on last week. Well, the square root of 36 is the number multiplied by itself that gives me 36.
6.
So it's 6, okay? Right, and the square root, and you probably, you might help yourself out by making yourself a little list.
So basically the square root of a number is the smallest number that can go into the number that you're trying to find the square root of.
The square root is that number multiplied by itself that gives you that number.
So what you said, no.
So if you make
Your
yourself a
gums are
little,
flapping.
you might get you probably want to get pretty familiar with some numbers, okay? And so what I mean is you should make yourself perhaps a little chart like this if you're a little uncomfortable. So 2 squared is 4, 3 squared is 9, 16, 25, 36, 49. You know, and then 2 to the third
8.
is 8, and this is 27, and then this one is 64. Okay, and 125. And you probably don't need some of these other here, but like 2, you know, 16, 32, 64. So I don't think you should fill in everything on your chart, but you kind of want to get familiar with the fact that the 6th root of 64 is 2, and 2 to the 6th is 64. And if you have yourself a little list, okay, some of the numbers out here you're never going to see, but some of the numbers you're going to see a lot of. Certainly like the ones that I've kind of drawn here. So if you're filling out your chart and you go down to like 10 or something like that, you're probably never going to have to know what 10 cubed is, okay? But you might need to know what 2 to the 6th,
thousands.
okay? Yeah, 10 cubed is 1,000. It's a pretty easy one because 10 is an easy number. But still, you know, there's a certain bunch of them that you're never going to see in the book. There's a whole bunch of them you're going to see all the time, okay? So the more familiar you get with these numbers, the quicker you're going to be able to change from the square to the square root back and forth, okay? And if you just have yourself a little chart on test day, see, it's nice to speed you up a little bit. You just look at yourself a little chart. And as you go along, you can fill out more and more spots on the chart. You can have a pretty comprehensive chart. And not a bunch of numbers out here that you're never going to see. You know, you're never going to be asked 6 to the 6th, I don't think. Kind of thing, okay? But 2 to the 6th you might see, okay? And so as we work through the exercise, you can see various numbers thrown at you involving certainly the square roots and the squares, but some higher order ones too, where you have to think like the third root of, like certainly I think you're going to need to know 3 to the 4th, okay? And you get a
3,
little,
4, 5, and 6.
you know, I would go all the way down to 10 with these numbers, but some of the numbers I would not go all the way out to the 6th root for, but certainly the smaller numbers I'm going to want to know the 3rd and 4th roots on, you know, because you're just going to see them. And it's going to speed you up if you know them. And you can make yourself a little list, or you can just, you know, you have your calculator handy and use your calculator if you want, whatever way you want to do it. Okay. I mean, look at down at the bottom of 481. Look at this. They've got the 6th root of 729.
So basically we need to find the number times itself.
6
equals
times
7.
that equals 729. Okay. You know, so like you might try something like 3 times 3 times 3 times 3 times 3 times 3. Is that 6 of them? You know, so this is 27. This is 81. This is 81 times 3, which is 273. And 270 times 3 seems to me it's 729.
Mm-hmm.
Okay.
So it's 3 then.
Yeah, so it's going to be 3. The 6th root of 729 is 3. But I mean, you look at that, you're going to say, I have no idea what that is.
Yeah.
Because, you know, you're not used to trying to think about 729 at all, let alone the 6th root of 729. Okay? So we go out here, we can put that one in. And then if we see one on the test, we say, hey, 729 being like an intimidator. You got your little list. It becomes an empowerer, or whatever it actually.
You're empowered by it.
Actually, yeah, I needed some other word that flitted in my head is the opposite of intimidator.
Under
You know.
example,
Accelerator or something.
Under example.
Invigorator, what, something, I don't know. Yeah, okay, so, and that's what this first part is about. And I didn't hear you, Jason, but you were asking me something.
Practice problem 1A.
Yes. But we're not really gonna, we're gonna get something.
Okay.
We're gonna get, 12 minus 3,
Right.
which is 9, square root of 9. So f of 3, by the way, is 3.
Okay.
Okay?
Okay.
And, we could be asked to do f of 1 or f of whatever, and whatever we get, that's, we just put it into this machine and crank the crank, and out comes the result, which is kind of what function means. Okay? 1/n. This equals, I'm not sure I'll write it down.
And
The definition is on the top of what page?
Top of page 484.
I needed you to say that on camera. Thanks. Oh, that doesn't look fun.
Okay? Which means that this would be 4 to the third square root of 4 to the third. Would be another way to think about this.
So you just change that into a radical.
Yes. We take whatever's down here, it becomes the root that we're taking. Okay? And this becomes what goes inside the radical. Okay?
Okay, and then what do you do with it?
Again, some practice problems will help you see, and we have to be able to go both directions. We have to be able to go from something like this into something like this,
And then from something like
and then
that.
something like this back up the other way. You need to have both those skills,
Okay.
okay? Like everything in math, we have to be able to multiply it, and we have to be able to divide. We have to be able to add, and we have to be able to subtract. Okay, they're opposites of each other. Again, these two things, we need to be able to go both directions. So, for instance, they have as practice problem
5?
5 there, 5A, very easy one. Okay? If we take this back out of here and follow that rule, we have x
Over 1. X.
which is
X.
x. It should make sense. The cube root of x cubed, of course, is x. The square root of x squared, of course, is x. You see what I'm saying?
Yeah.
So you probably could do that without going
Gotcha.
through the rule. Okay?
So then B would be Y.
Yes, b would be y. But now go down to practice problem 6a, which is the 4th root of x cubed, and tell me what that is.
I mean, to write it in,
So yeah, we're x
4 with,
X and 4 over
4,
3?
4,
3
oh, 3 over 4.
No, 4 over 3.
No.
Or is it 3 over 4?
3 over 4.
Okay, according to this, the denominator goes to here, or
Yes.
here goes to the denominator. See what I'm saying?
Right.
So 4 is the same as this n up here. And where does the n go? The n goes into the denominator. Okay?
Yeah, because the 4 would be the numerator.
Right? Now, I don't know how many times you have to practice it before this becomes like second nature.
Yeah.
But the object would be for this to become second nature before the final.
good luck with
You know, not
that.
necessarily, I mean, we're gonna probably have 14 questions again. If you miss one of them, so what? So sometimes you just say,
Well, I don't
this
want
one particular idea, sometimes you write it off.
Yeah. Well, I
Okay,
kind
you
of
know- you
like
know
to
what I
not
mean?
do that this time.
X, 7.
So XY to the, you're too fast.
X, Y to the 7/5. That's what I thought. Good. I worked that out.
Wait a minute, where is that? This is practice problem 6B.
This is the way it is. You give the rule and it doesn't get into your brain too well, but when you start looking at the practical specific cases, then the rule starts to become relatively clear.
So this is practice problem 7?
Yes, and we're looking at 481 x to the 12th.
Oh, that's the one down there.
Okay, so this is practice problem 7A, 7A.
So would the answer be 81x cubed?
Yeah, she's got it already. I'm just walking out of the room.
Would it?
I don't walk out.
I'm going to use my chart here.
Okay.
Okay, whenever you see a number like this inside the radical, think about writing it as an exponent. Same as what we earlier, gave you this idea earlier. So before I do anything to this one, I'm going to write this as
So you transform it into an exponent.
yes.
Okay.
Okay? Because it's hard to tell how to use this rule when it's just this number.
Big number, yeah.
Okay? But when you take this number and turn it into what it is with exponents.
Again, going back to simplifying it and,
Yes.
Okay.
Then suddenly the rule is now applicable.
Yeah.
Okay? Because now I can take this. This becomes 4 over 4. Which of course, you know, because
One.
4 goes on the bottom, and this 4 goes on the top. Okay?
Yeah.
And x becomes x 12 over 4.
3.
These things are the same. Which is really, of course,
3x.
3x cubed.
Yeah.
Did you do that right?
Third.
She already had that. So you for rent? I'll pay you.
Is it?
Can I take you home with me?
And that's because anytime you have something inside the radical that has an exponent that matches here, it gets to come out of the radical.
Okay.
And so you know, like 3 comes out because 4 over 4 is 3.
Yeah.
Okay? But x to the 12th, if you think about what x to the 12th is, it's x to the 4th times x to the 4th times x to the 4th.
So it's really x
So
to the third.
3 x's came out, x to the 3rd.
Third.
You see what I'm saying?
So basically you divided the 12 by 4. Okay, I mean, would that be a standard procedure to say,
Yeah.
you know, like,
Yes.
x squared y?
When I multiply this, things are going to cancel, right?
Oh, you're gonna do that before you multiply?
Well, that's part of multiplying. Remember, if you're
Right,
multiplying, you
yeah.
cancel something, okay?
So 3x squared,
I'm going to get 2y there, right?
yeah,
You see what I'm saying?
right.
And when I multiply this times the second term,
You're gonna get x squared y.
the y's are going to cancel.
Well,
I'm going
wait a minute.
to get 9x squared.
Okay. I just got it. Okay.
See what I'm saying?
Mhm.
Yes, Jason?
Yeah, kind of.
Okay, when I multiply this one times that, the y is going to cancel, one of the x's is going to cancel, and I'm going to get 3x times 5, right?
Yeah.
Which is 15x. When I multiply this one, I'm going to get minus 12x squared y. And then I just have to simplify if there's something to simplify.
Okay.
No fractions,
Right. But
which is what we're
then-
trying to do.
But then we could factor it out further, right?
A little bit further. This one has common terms on both sides.
Right.
This one here does not. I don't think there's anything we can do to that.
No.
Okay? But this one here, we can take out the 3x. Whoops, take out the 3x. Didn't I say out? Take out the 3x. And then inside, you've got 5 minus 4xy. This is our answer.
Yeah, I see that.
So do you always put, when you're finding the lowest common denominator?
When you find the LCD, then you're going to multiply it both the top and the bottom.
And you always put it over 1?
I wouldn't normally write the 1 down, but I want you to understand how it's working. Remember, when you're multiplying, you get to cancel anything top to bottom that's the same. So sometimes you forget that this is a top.
Right.
So I wrote it over the 1 to remind you that it's a top. Okay? And I wouldn't personally write it down because I don't need the reminder that it's the top. But you know, when you're demonstrating something to somebody, you know, you break it down a little further than you normally would do yourself. You see how much easier this way is? You find the least common denominator. You're going to multiply both sides of the equation by the least common denominator. Remember, if I do the same thing to both sides, the scales stay the same. Okay? Why the least common denominator? Because it's going to cancel out all the denominators. Then I'm no longer going to have rational expressions. It takes it back to a place I already am supposed to know how to do the math for. Okay? Well, we'll see. Remember, I'm going to go, when I'm doing a polynomial, this times that and that times that. When I do this, the x's cancel. And Jason, this is where you're having trouble with last time, so you want to watch that. When I multiply this times that, I get 15. X's cancel, 5 times 3 is 15.
Oh, so we're supposed, you gotta break them down and do it each one step at a time.
One step at a time.
Okay,
Sure.
so that's why the 5 didn't cancel
That's right.
starting out.
Now, when I do this one, the 5's are going to cancel, and I'm going to get 4x. Right? 5's cancel, x times 4. Okay? Over here, the x's cancel again, and I get minus 10. Okay? Now, do we remember how to do this? This is really old school. Okay? I want to get x by itself. I get x by itself by undoing every operation that's done to x.
Wait a minute, could you back up one? How did you get it for x?
5x times 4/5.
Oh, okay, I didn't see, okay, I didn't see that.
And what I recommend, see, this is what my isolation thing.
Yeah.
Okay?
Yeah.
You take it and you work it over here.
Right.
Okay? And you isolate it. Like NCIS LA, you know how they got that computer where they move everything around? Just take it, move it over here, work on it by itself.
Yeah.
Okay? Did I tell you my fish analogy? I was watching the show about like the great reef and the wildlife of the reef. And they were talking about, you know, the dog-eat-dog world of the reef, you know, the food chain. And one of the species is this fish that swims in schools of like hundreds of thousands of them. This other bigger fish eats those fish. But when they're in the school, it can't eat them because it chases after one, it gets distracted by another one. It chases after that one, it chases after, and it never gets a fish. But if it can chase them up in the rocks and separate them, then it's fast enough to go eat one.
Right.
Get my analogy? Sometimes the problem looks so busy that we can't
See which one,
see
yeah.
it. And you break it down step by step, and the problem becomes easy.
Yeah.
You put the chain together, and you're done. Okay, so I'm going to subtract 15 from both sides, because 15 is being added to x. Okay? When I subtract 15 from both sides, I get 4x equals a negative 25. Now, x is being multiplied by 4, so I divide both sides by 4, and I get x equals negative 25/4. That's my answer. This is practice problem 1. Steps are, find the least common denominator. Multiply both sides by the least common denominator. When you do that, the denominators will all cancel, and you're left with a problem that's supposed to be routine. Okay? Certainly if I were teaching freshmen in high school, I would consider this a routine problem. Okay?
No, thanks for making me feel old.
Okay? Least common denominator is?
2x plus 1.
That's right. So I have to multiply both of these by that. Okay? 2x plus 1 and 2x minus 1. Okay? And then over here, 2x plus 1, 2x minus 1. And then it's so beautiful because now things get to cancel. No more denominators, see?
Is that a y under your 25?
See, now you have to write, now I gotta
4.
write it different.
Oh.
Okay? Oops. The wrong one. Okay, 2x plus 1 and 2x plus 1 cancel. I get 4 times 2x minus 1. And then over here, the 2x minus 1's cancel. And I get 6 times 2x plus 1. See, I don't think you should copy these down.
I'm trying to work them by myself as I.
Okay, good. You see what's going on, and then I agree, you'd want to have it in your notes to check, but it's already in the book, so when you go to check, you can just look in the book. You don't want to copy stuff down off the board the teacher's going to give you a handout for, would you?
Or you have a video camera for.
You know what I mean? If I came in and I gave you a handout, and then I went on the board and did everything that was in the handout, would you write notes on what I was doing on the board? No, you have the handout to refer to. You want to pay attention. See if you can figure it out by listening and watching, and then you have the notes to back yourself up on. Okay? So I understand the idea behind taking notes is a good idea. Have them in your books, but when the notes are already provided for you, it's a redundancy that I think sometimes gets in the way because you're not watching what's going on. You're busy copying down, and you're missing stuff. Okay? And I might be going too fast for you to be copying down and getting stuff. So I'm a little worried about that. So I just mentioned it. And then you guys are big, so you do what you want. Back to pretty easy stuff. I'm going to distribute the 4 through here, so 4 times 2x is 8x, and 4 times a negative 1 is a negative 4. Over here, 6 times 2 is 12x, and 6 times 1 is 6. Now, I need to get x by itself. In order to get x by itself, I first got to get them together. Okay? So I'm going to subtract 8x from both sides. Do I have to do 8x? Could I do the 12x? Yes. I chose 8x because it leaves me with positive numbers. Okay. Okay. You could do it the other way. It's all going to work out. Okay. So sometimes it's a matter of choice. Style. Okay. Minus 4 equals 4x plus 6. Now I got to start getting x by itself. Subtract 6 from both sides. Minus 10 equals 4x. Divide both sides by 4. And x equals a negative, what is that, 5/2. Reduce it. Again, the drill is find the least common denominator, multiply both sides by the least common denominator, and after that, everything is routine. Everything is already something you've learned previously that you're starting to get proficient at.
One is a sister by blood, the other one is a dear friend who's just, we're just family. Yeah, we're just family. But yes,
So one's a sister and one's not a sister.
in a manner of speaking, if you want to get technical, yes.
Well, these days, you know, with half-sisters and whatnot,
Yeah, I know.
it really is pretty complicated.
One's a sister by blood and one's a sister by choice.
Mm-hmm.
And one's a member of an order.
There you go.
It's like Dominicans or something.
Now, the difference between two squares.
Yeah, so I'm guessing, what's our least common denominator then?
X plus 2, x minus 2.
Okay, so x plus 2 and x minus 2. Okay? And over here is the same. This is x plus 2 and x minus 2, so this is going to cancel, right? I'm not even going to bother to factor it out for you. Because I'm speedy results. So on this side I have x minus 1. Now over here, when I do the first one, the x plus 2's cancel. So I get 2 times x minus 1. Okay? And then when I do the next one, the x minus 2's cancel, so I get plus 4 times x plus 2. again, from here on, I just gotta think you should be able to do this.
You really? Okay.
Well, you know, I'm trying to think about, you know,
You're trying to think
separating out from people that don't pass 130 and people that do pass 130. You know, you can't do this, and I really shouldn't say you passed 130.
about, eventually I will be
You know what I
able to
mean?
do it.
Okay, so 2 times x, 2x, 2 times the negative 1, negative 2. 4 times x, 4x, 4 times that's 8. Put your x in. Say it, write it. Okay? You got like terms. So over here, this is 6x minus plus 6. And over here is x minus 1. I'm going to take that x over. At minus 1 equals 5x plus 6. Subtract 6 from both sides. Minus 7 equals 5x. Divide both sides by 5. Minus 7/5 equals x.
Sure.
Just to make sure you understand. This is what we're learning here. This is the new part that we're learning. All this stuff is old. This is new, this is old. Okay?
The way I remember it being taught to me is not the like minus 6, subtracting 6 from the left and the right side. We were told that once you
Same thing.
bring it over,
As you move it, the sign
you change your sign.
Okay, so don't get too busy filming
I
that.
know.
Because that makes it 4 here. Okay. And that makes this 4 minus 4, which makes it 1.
What practice problem is this?
Practice problem 3. Okay. Which makes it minus 5, which makes the answer minus 1. And you know, I was surprised we got fractions 3 times in a row. Usually they have some problems that work out nice. Now this is root, and it's not something you get done at the dentist office.
Although it does sound like
It does sound like a little pain. And there, it boils down to, like in this problem, you all are aware of the fact that I cannot divide by 0. That dividing by 0 is undefined. Yes?
yes.
So if I got all the way down, my answer had been minus 2. It can't, minus 2 can't be the answer. Because then I would get 0 here. Can't divide by 0. The answer could not have been positive 2. Those are 2 things that could not have been. So when you get down here, you have to check. You have to go back and see if your answer really is an answer. Because the teacher might get tricky on the test and slip one in that's not.
Not our teacher. He wouldn't be
not ours.
that mean.
Okay? Because it's just one of these things you're supposed to do always in math, and usually like in every job, when you're doing your fabric and stuff, you're supposed to check. Okay? Because you don't want to be there putting a siding on your house and find out that you measured wrong. You've got a board and you've got like 5 inches of open house because you didn't measure. So you know you're supposed to check and double check and then check again or something like that.
They did that in Tacoma with the bridge, the curve.
And 7.5 is about the fact that occasionally you can get something that you've worked out, appears to be a solution, but is actually not a solution. Okay? The book says, equations containing rational expressions sometimes appear to have solutions when in fact they do not. By this we mean that the solutions we get by using completely correct methods. See that? You can do it completely correct. But what you get, that this particular problem has no answer. Okay? Because what you get using correct methods turns out to be undefined. It's dividing by 0. So if you look at example 4, they've done everything right. This is on page 452. They've done everything right. You come down to the answer, and the answer is 2. But if you look back at the problem, it cannot be 2 because that creates 0 in the denominator. Okay? And that's exactly what's going to happen with practice problem 4. When we get all done solving it, we're going to get minus 1 as the answer.
And that won't work.
And then minus 1 won't work. So what you put on your test, if you think that that's what you think, then you put no solution. You show your correct method,
And then
You put the thing in, and then you just put on your paper, no solution, okay? You can't be 1 because 1 makes it 0, and 0 is undefined in the denominator. Yes? Okay, then we're ready for homework.
Oh, sure, okay. If you think so.
Well, I think that you need to practice hands-on.
Yeah, I do.
Add cancel x squared plus 8x equals a minus 15. X squared plus 8x plus 15 equals 0. Factors of 15 that add up to 8, 3, and 5. Okay? So this is x plus 5 times x plus 3 equals to 0, which means x equals minus 5 and minus 3. Yes, those are the solutions. When I go back and check, they're not going to make the denominator 0. I don't have a no solution possibility here. Okay?
If it's the same variable, why is there 2 different numbers?
Why are there 2 answers?
Yeah.
Because it's quadratic, because it's squared. 2 different answers are going to work. So I know intuitively it doesn't seem like there should be just one answer to things,
Yeah.
but frequently there's more than one way to do something.
Yeah.
Okay? So when we put these in, what happens when we put minus 5 squared plus 8 times minus 5 over 5? Does it equal negative 3? This, because of the square root, you see, the negative 5 becomes a positive 25.
Oh, yeah.
And this becomes negative 40, which of course is negative 15 divided by 5, which is of course negative 3. Checks. Okay? When I put a minus 3 in, does a minus 3 work? Minus 3 squared plus 8 times minus 3 over 5. Does that equal minus 3? When we do this, we get minus 24, positive 9. 9 minus 24 is minus 15 over 5. Yeah, checks. So
we have to do the same thing, you know, it's like, if you've got 2 minuses.
does anybody? Yes, we would. Okay, so like one of the rules of exponents is that if I have x squared times x to the 7th, that equals
X to the 9th.
x to the 9th, okay? Because you add exponents. Okay? But when you're doing this, something like this, if you have x to the 3rd times raised to the 4th, does anybody know what the rule is for that?
Multiply them.
You multiply them.
Oh, multiply.
And if you thought about it, you could see where it comes from.
Yeah.
Okay? Because if you remember what x to the 4th means, it's x to the 3rd times x to the 3rd times x to the 2nd, which would be 3 plus 3 plus 3, which is 12, and the shortcut is 3 times 4.
Yeah.
Okay? So this would be x to the 12.
So
Okay?
then that would be 3x.
The question is, do you know what to do with this? What do you do with a negative exponent? Let me give you, this is the general, let me give you what is x to the negative 4th? Anybody know?
If they're even, then they go to positive. If they're odd, they go to negative.
Yes. Wouldn't it be like x minus
So-
multiplied by
Is
You
it
multiply,
positive?
but still, you multiply
So go ahead
3
and look at
times 2.
But I'm asking you, there's no multiplication here. Tell me what this is.
Oh,
Oh, x to the negative 4th power.
It's a 1.
Yeah, 1.
Now look at your book. Look at the rules that you're supposed to, okay? So x to the negative 4th equals 1 over x to the 4th.
okay.
This is the rule. And we went back to 5. I think they actually show you how this is the rule, but just learn it. Or discover it, whichever way you want to go, but this is the rule. Okay? So how about this? Is this in the book? What do you think that is?
X to the positive n.
Yeah.
Yes, it is. Now let's try applying that in here. So this is going to be 3, this is x to the negative 2, which is really 1 over x squared, right? So x squared goes down and becomes positive. The x to the negative 5th is like this one, so it goes up. See, up. Okay, so x to the 5th is up here.
So it just jumps the line.
Yes, numerator, denominator.
Okay, see what's gonna throw me now is, see, I would want to bring the 3 down also.
I got this 2 off. The 3 does not, it's not, the exponent for 3 here is a 1. Okay? It doesn't have a
So
negative
you can
exponent.
separate
If it was
the
3
two.
to the negative 2, I would bring
The
it
3
down underneath.
yes.
Okay? I would then have 1 over 3 squared. Okay?
Where
Now, I'm going to cancel before I do this negative 3 up here.
Okay, where did you get that 2 in the denominator? 2x squared. Okay.
Crisscross applesauce, because of these 2 rules.
Okay.
Okay? So if you have a negative power, okay, and it's in the numerator, it becomes a positive in the denominator. If you have a negative power in the denominator, it becomes the same power positive in the numerator. Okay? Right, because this one, if you think about this one for a second, based on our first rule, this is 1 over x to the n. Which, of course, if you're going to divide 1 by a fraction, you have to flip and multiply. So you get x to the n. Right? So this one goes up, and this one comes down. If you want it without any math talk. How?
Oh, okay. So
Because of the rule. X to the negative 4th is the same as 1 over x to the 4th. Okay? So x to the negative 2 is the same as 1 over x to 2. So 1, so nothing changes up here, but x to the 2 is down here.
So in order to simplify it, you're almost taking the exponent out of the equation, changing it.
I'm flipping it from top to bottom. All I'm doing is flipping it from top to bottom. And then bottom to top. Here it's on top, negative. Down here it's on the bottom, positive. Here it's on the bottom, negative. Here it's on the top, positive. I'm just flipping it from the numerator to the denominator, denominator to the numerator. And then changing it from negative to positive. Okay? Now I get to cancel. This is x times x times x 5 times, so I get to cancel these x's. Okay? And now this is x to the 3rd. Because you just subtract. Again, that's one of your old rules sitting there. And then here, again, this becomes 2. Okay? So now I have 3 times x to the 3rd y squared over 2. Now I'm going to do the distribution that Samaria was talking about. I could do it first.
Excuse me.
Okay? Could do it first. It will work out the same, but I like to simplify inside and then do this. Now all of these things are going to be multiplied, so this becomes 3 to the negative 3rd, and x to the negative 9th, and y to the negative 6th, and 2 to the negative 3rd. Yes? Now what do we do with negative exponents?
Take them across the line.
Flip them across the line. Okay? So this is 2 cubed over 3 cubed x to the 9th, y to the 6th.
Okay, back up.
yeah, I'm way lost.
How did, I understand x to the negative 5 is 1 over x to the 5th.
Okay.
I understand that. How did x to the 5th end up next to 3?
Can't
in the next,
canceling. We've got x to the fifth is, okay?
So do you just cancel out 2 of them? Or you cancel out 3?
Oh, then I have x cubed.
Oh, okay, yeah, you're right. So you cancel out the 2.
Or I can do the rule. The rule is if I have x to the n over x to the m, this equals x to the n minus m.
why doesn't x to the fifth stay next to the 2 where it started? That's what I'm asking.
It's
Why wouldn't it be,
negative
why wouldn't it be 2x to the fifth on the bottom?
because of this. Look, let me say this again. If you have a negative exponent, you move it to the other side of this line and make it positive.
And that's the rule.
That's the rule. I mean, that's a
When you-
colloquial way of saying the rule. This is the rule, okay?
Okay.
But you just want to put it in words you understand. You just take this and put it, it goes up here. And you take this one and it goes down there.
Okay,
What
so,
I mean by down, let me get all some of the mess out of there. Oops, I don't want to ruin the answer. If we just had, if we just had this,
It would be x to the fifth on, in the.
because this is
in the
negative,
new one.
here's our line. So this is up
Yeah,
and this is down, okay? This one, because of the negative, goes
down here, and that becomes x squared.
And this, because of negative, goes up.
and since the x's are both x's, okay, say if like it was 2 on top and 3 on the bottom, 2 minus 2 to the minus 2 power,
Okay.
square, second
We
power,
got x 2 to the minus 2,
2, yeah,
2 to
2,
the minus 2, and 1.
and over 3. So, minus to the negative fifth power.
Okay, if we had this,
Then the 3
This
would
would
go
come-
up.
3 to the 5th over 2 squared.
Okay, so the reason that it didn't do it over there is because we were both having x and x, right?
The reason we didn't do it here is because we had, this is positive right now. It's a positive 1, this is a, and this is a positive 1. There's no,
Oh, I understand your question, but it's.
No, on the top one, it's 3x to the negative power, 2x to the negative fifth.
yes, the 3 is not to a negative power.
It's just
Right.
x.
It's the
So,
x that we're
the reason that we didn't switch the
3.
thing is because both of the x's were x's.
Now,
We only switch the things that have negative powers.
Right.
We're talking about what to do to things with negative powers.
I-
Okay? The numbers do not have any negative powers.
I think she's talking about since the x's are the same, is that what you're saying?
Yeah, since the x's were the
But
same,
X, yeah, x is x.
but if they were like 2 and 3, then you'd switch it. I mean, not those two, that 2 and 3, but,
Anything with a negative exponent is going to switch. This is 8 over 27 x to the 9th y to the 6th. This is your answer for this one. Okay? Yeah.
On that last part, before you simplified it, the 3x to the third, how did you deal with the negative 3? Did you just flip it?
Okay, this negative 3 right here. Now I'm gonna erase that part there. Sam.
Okay.
Let me put it back up.
Okay.
You know, I got kind of excited. Okay, now I've multiplied, just like this rule that we had a rule up here on the board, and it's in your book. If you have x to the n raised, this is the same as x n times m.
Yeah.
yeah,
So this is a 1, 3 to the first, times a negative 3 is 3 to the negative third.
Okay.
Okay, this is x to the negative 9th, because a negative 3 times a positive 3 is a negative 9. Negative 3 times 2 is a negative 6. And down here, I get 2 to the negative third.
So is that only to the x? No, I see.
Now,
I just get a little confused about the negative 3 times 3, which equals 3.
this is a 1. We just don't write the 1 because
Yeah.
it takes time.
Yeah.
So 1 times negative 3 is a negative 3. Okay? Jason?
in order to get x by itself on the bottom and x by, relatively by itself on the top. You're subtracting 2 from 5,
Yes.
and you're subtracting 2 from both sets. You're subtracting 2 from 5, and you're subtracting 2 from itself.
Or are you, Jason?
No,
No. Okay.
no. I'm subtracting 2 from 5, and then I'm left with x to the third.
So what happens to the 2 on the bottom now?
Well,
Does it just cancel out, or how does that work?
so here's if you're doing. Okay, so if we had x to the 7th over x to the 4th, okay, we're going to get x to the 7 minus 4
Which would be x to the third.
third, okay?
Okay, so it's not canceling, it's just subtraction.
Yeah, and the reason why the subtraction works is if I had it all written out. Remember, I think I told you math is all about shortcuts.
Mm-hmm.
It's an abstract way of doing real life problems, it's shortcuts, okay? I could write this all out, but it's a pain in the butt,
And you'd probably kill many trees.
you know? And then it would be canceling.
Mm-hmm.
See, what you notice after you cancel a bunch of times that, hey, this is 7 and this is 4, and I end up with 3. 7 minus 4 is 3,
Mm-hmm.
okay? This one was 5 and 2, and 5 minus 2 is 3, but if I did it the long way, remember, like my area thing that we started class off with, the long way is counting every one of those little squares. The short way is multiplying the two sides, okay? The long way is canceling, writing it all out. And canceling, and what you do, a few times of doing that, and you notice that, hey, 5 minus 2 is 3, and that's what's left. And then somebody says, hey, this is the rule. The rule is because it really works that way. Right? And the rule is usually a shortcut.
Okay.
Now, you know, you guys are, students are frequently being taught something that somebody else has already learned the rule for,
Mm-hmm.
and then you don't learn the rule yourself, you're just told, here's the rule, do it.
Yeah.
You understand what I'm
Yeah.
saying? And so sometimes you don't get the rule because you haven't had to do the dirty work
Yeah.
that makes the rule
Makes
make sense to you.
Makes sense.
Okay? So there's two kinds of ways to handle that. Is you got to go do a bunch of math to see that the rule works. And then you say, oh, I get the rule. Or you say, I'm just going to believe the math book and the math teacher, and I'm just going to roll with it. I don't need to do it the concrete way.
Yeah.
So, because you know all that stuff with circles and stuff like that, the Greeks did it concrete. They did the circles and they did the measuring, and they did it, you know, they did it a different kind of way. And then we get a theory, the abstract, because it's been passed down for 2,500 years, and we just learned that. What's going to happen when we have rational exponents? Okay. What was the rule?
Oh, you know what threw me right away? I was looking at the problem there. Instead of the line,
But then there's visual difficulties, you know, because this book has access to better computer programs than I do. Okay, so what am I supposed to do here?
multi-
I have to multiply 4 times 3/8. Okay, just like any simple little fraction problem from back in whatever grade that is.
Very funny.
No, really, seriously, but you know, it piles up. Okay, and when I do that, remember we're talking about factoring and canceling. If I factor this, the 4's cancel.
But why would you factor it instead of just canceling?
That is why canceling works. Most of the time, I don't show you the factoring, but I need you guys to understand why factoring is so important. It works because 8 is 2 times 4.
Yeah.
And that there's a 4 up there. But, you know, most of the time I don't have to show you that. Everybody knows that 8 is 2 times 4. And then therefore the 4's come out because 4 over 4 is 1.
Uh-huh.
Okay? But, so this 4 times 3, or you can do it the long way. You know, the long way is you get 12 times 8. You get 12, you know, straight across the top, straight across the bottom. If you don't cancel first, then you have to figure out what 12, you have to simplify 12/8. Canceling is the simplification process ahead of time. This way, I get 3/2 as my answer. The answer is, this is x to the 3/2.
Okay, so.
Okay, because 4 times 3/8 is 3/2. Okay? Now, let's try their next one, which is x to the 3/7 divided by x to the 2/7. Just, Jason should be the one giving us the answer to this one.
Why do you hate me?
Multiple
Why do you
reasons.
think that I hate you?
Because it's math. I'm kidding.
Because this is the subtraction one that Jason was just wrangling with us about, so I thought it might be, when you see an exponent divided by an exponent, the rule is subtract them.
So then it becomes x.
So this becomes this very simple fraction problem. And what I mean is simple is because I already have least common denominator. All I have to do is 3 minus 2.
So it's x is 1/7.
Yes. This is x equals 1/7. I mean, x to the 1/7 power. Okay? And again, it kind of looks, so we started off a half hour ago talking about how busy math can look, and if you just think about it, this is really 3 minus 2. This whole problem is, can you do 3 minus 2?
Not always.
That is a pretty simple thing that all of us can do.
Sure.
Okay?
we can.
It's a little trickier for us to get to this place where we recognize it's 3 minus 2. That's all the problem is. 1/7.
And it's recognizing the process
Yes.
and putting it in form that people would understand if they looked at this and were looking for this specific.
Yes, okay. And I think what makes this one a little bit of a wrinkle is it combines 2 of the rules, you see? This one was just one rule, this one was just one rule. This one combines 2 of the rules. We have to know what to do with negative exponents, and we also have to know what to do when we're multiplying or dividing exponents, depending on what's going to happen here.
Okay, so in order to deal with a negative exponent, you have to turn it into a positive.
That's right. And it has to go at the bottom into the denominator. So this becomes 1 over x to the 7/5 times x to the 4/5, like that. Which is, again, 1 step at a time, is x to the 4/5 divided by x to the 7/5. And what are we supposed to do when we have exponents dividing
Subtract.
exponents? We're supposed to subtract. Okay?
So then it becomes x to the negative 3/5.
Yes, it would. It would become x to the negative 3/5, which we don't like to leave it like that, so it would become,
2. X to the second
how,
power.
what do I do with the negative exponent? 1
1
over,
Okay.
Yeah.
1 over x to the 3/5. Okay?
Can you just do from
Yes, you could.
the beginning?
Yes, you could. Yes, you could.
If you knew that to do that. If you don't, you're screwed. Oh, my battery's dying.
What am I supposed to do with this? Is this a negative 1/4?
Wait a
No,
minute.
No, it's a positive
Okay.
1/4.
So then no, by it.
so you
No.
just multiply.
What am I supposed to do with this x to the 1/4 and this x to the 1/2? What am I supposed to do with those exponents?
You're supposed to combine them in some way.
I am supposed to combine them in some way.
Yeah.
Now, I want to take that word "some" out and put something in there
You
that's
just
not,
add them
that's,
together.
I'm supposed to add them together.
Yeah.
When multiplying 2 bases that have exponents, you're supposed to add the exponents together, okay?
So would it be 3/4 or 1/6?
3/4,
3/4, okay.
okay? So, I mean, these fractions are small enough that you probably can do it without thinking about the least common denominator, rewrite the fraction thing.
Okay.
You know, you can think about this as 25 cents and 50 cents, 3/4.
And
Okay? But if you wanted to see it in terms of, you know, common denominator thing, 4 is the common denominator. So you write this as 4. What do I multiply this by to get 4? 2. You know? So this is 2/4 and 1/4. Now I can add them together and it ends up being 3/4.
So that's what I was gonna.
Okay? So you have to remember how to do adding fractions. Find the least common denominator, rewrite the fractions so that they have the least common denominator as their denominator, and then add the tops. Okay? Luckily, they give us some nice small ones. Again, then we're working our way up
to the more complex.
to a real problem, you know? So we end up with x and a fourth times x and a half is x and 3/4. And then a minus 3 times a minus 2 is a
-6.
negative 6.
But it's not a -2.
Who's a -3?
It's a -3, but it's not a -2. It's a +2.
Right? Did I say it minus 2?
Yes, you did. That was confusing. Okay.
I apologize for that, but we ended up with the right answer no matter what I said.
So, there.
So, well,
I'm just kidding.
visually, we did better than we did, auditory. Now, we go to this one, okay, and we don't have any multiplication of exponents, at least the way it looks. We have division of exponents, and we have negative exponents. Okay, so this one has two of them. We have to apply two of our little rules to. And again, we can kind of, approach it from a couple of different starting places. I like to make sure I have no negative exponents as my first starting spot, but it does not need to be done that way. Okay, so if you can remember all the way back to Tuesday, what that means is this y goes down here to y and a quarter down here, and this x and a third goes up here. Okay, so this is the same as 13 over 26 y, oops, it's going to be x to the 1/12 and x to the 1/3. And down here we have y to the 1/2 times y to the 1/4. Okay? And now we have, instead of division, which we thought it looked like we were going to have, we actually have the multiplication. Okay, we had the same base, we multiply those, we had to find the least common denominator, add the fractions. Least common denominator is 12. What's the equivalent in 12ths of 1/3? 4/12. 4/12 plus 1/12 is 5/12. Are you with me?
Yes.
So we have x to the 5/12 if I wrote the problem down right. Okay. Down below we have the same one as we had over here except for a y there. So this is y to the 3/4. Remember, I'm not going to add it again. I'm not going to go through it all again because I just got done doing it. So now I got it right there in my head, right? Well,
Theoretically.
yeah, you could do it that way. It's certainly the way I do it. Okay. Then we got 13 over 26,
1/3.
which is 1/2.
Oh,
Yeah,
very
1/2,
good.
yeah.
Okay. Because 13 times 2 is 26.
Yes.
Okay, so this is 1/2. Okay, and so our answer would be, assuming I wrote everything down right, certainly the answer for the problem I wrote down would be this.
Very simple.
Yeah, seemingly. Okay? A little bit busy to start with, but again, if you just do it one slice at a time. Different variation of these exponent rules. So we have minus 3x to the what? 1/2 quantity 2x to the 1/4 plus 3x to the negative 1/2. Is that right?
I'm looking. Yeah.
Okay. This one requires us to do distribution and then whatever exponent rules we need. In other words, we have to do this term times that term, and then we need to do this term times that term. So we're multiplying these, which means we have to add those fractions. And again, we have the 1/2 and 1/4 for the third time, so by now we should be getting that down. So that is going to be a minus 6 x to the 3/4. Okay? Then when we do x times 1/2, we add 1/2 and a negative 1/2.
No. I mean, you could.
Doesn't that look like what we're going to do?
Yeah, it's a 0.
Well, shouldn't we?
And what is x to the 0? Does anybody know?
0,
It's 1.
1.
So minus 3 times 1. Oops, negative 9. Okay?
Well, wouldn't you turn it? Why wouldn't you flip it?
I could flip it. And if I did, it's going to do the same back channel. Remember, I'm talking about what your starting point can be different. If I flip it and I have x to the 1/2 over x to the 1/2,
Yeah,
Doesn't that cancel out to 1?
yeah. Okay.
Okay?
Yeah.
So it doesn't really matter which direction. If you follow every step properly, you can come at it from a number of different directions. It's all going to take you to the same place because these rules are self-consistent. And that's why they're there. It's not just some mathematician decided to bust everybody's chops. That's not what's going on. Okay? So, then that would be the answer unless they want us to factor. You see, we might have to factor a common factor out of there. But certainly could. We'll just leave it like that. Okay. Practice problem 5. Slightly different thing. Can I erase this? We're good?
Yeah, knock some out.